What up, nerds? I'm Bryson. You can call me Bammed, and this is CTF and Cigars by Bam CTF, where I light up a cigar and talk about CTF, security, and hacking and related topics. Um, so uh, Today I'm smoking one that I had. I think I did this last week, maybe the week before, but this is another cigar from the AJ Fernandez sampler. Um, I think I've gone through all the different varieties that I had in that sampler, but this is one that I've still got. I think the sampler, I got a mega sampler that came with, I believe, four of multiple different types of cigars. So I've still got some of these, but everything else I've got in my humidor is already something I've smoked on the show. So I do have some more stuff coming in. But yeah, this is what I'm smoking today. It's AJ Fernandez Relic. Um, and if you want to go back and see, I've talked about it before, but just a quick review. So the aroma is chocolate and a little bit of damp wood. Actually, it's mostly, it smells like damp wood with just a little bit of a hint of chocolate to it. And when we start smoking it, the first third starts off kind of sweet, sort of a cola flavor with some earthiness and coffee. And then we get into the second third, and it's more of a natural, like tobacco flavor, some cocoa, and get a little bit of white pepper, and that sweetness wears away, becomes a little bit more bitter. And then that final third, the cocoa becomes more like dark roasted coffee, a little bit more bitterness, and then there's some earthy sort of hay and pepper for that final third. So let's go ahead and cut that. And again, today I'm using the V cut. So there is the V. Let's light this thing up. And then we can get into the hacks. So this week, and actually this month, I've been going through the advent of Cyber 2. This is by TryHackMe. It's on tryhackme.com. So they're doing a daily challenge starting with December 1st, going all the way up to Christmas the 25th. Now hold on. All right, that's lit now. I missed a couple episodes beginning of the month, and so I'm a little bit behind, so I'm getting caught up this week. So today I'm going through days 17, 18, 19, and 20. And then I'm going to stream again tomorrow on the 24th and do days 21 through 24. So then I will be caught up. The final day, which will be on Christmas Day, I don't plan on streaming on Christmas Day, but I'll catch up on Saturday at my usual time. All right, let's take a look at today's challenges. So we've got day 17. Now we're getting into some fun stuff. We've talked actually quite a bit on this show about reverse engineering. We've done a number of crack me's several times. We've done some game cheats using Cheat Engine. But yeah, day 17 and day 18 both go into reverse engineering. So we're going to start off with x86-64 assembly. And yeah, there's kind of a basic primer here that talks about the x86-64 assembly. It talks about using Radare or Radary. I'm not exactly sure how that's pronounced. I've seen it pronounced a few different times. I usually go with Radare, but I think Google told me it was Radary. So however you want to say it, but yeah, this is the tool, and to be honest, I haven't used this much. I've used a lot of other debuggers. On Linux, I usually use GDB. On Windows, I've used IDA and x64 debug and x32 debug and Ollie debug, and Gidra and Cutter. So I've used a lot of them, but I haven't really used this Radary framework much. Really, I think this was the first time I played with it. So this was actually a learning experience for me as well. So let's see, we're getting started. I've already deployed the machine, so we're going to SSH in the machine. I've already done some of the basic work getting started here because it takes a few minutes where we just sit there and watch the screen, and that nobody wants to just sit here and watch me watch the screen. So I've already started this up, but we SSH into the box, gives us an IP, gives us, username and password here. Then we launch Ratery. Now, when you SSH in, there are two files. There's a file 1, and then there's the challenge. And so the tutorial here walks through how to reverse engineer using this first one, which is file 1. So the first thing you do is you've got to analyze the program. So we launch it, and we analyze it with the AA command. And that's the part that it says right here. This can take 5 to 10 minutes depending on your system. So I went ahead and did that before I started the stream. So that's done, and I've printed the main function here, so we can already see that. So that's, if we keep going, so once the analysis is complete, where do you start your analysis from? And so you can find a list of functions with the AFL command. So we can run that here and see there's all the list of functions, but specifically we're looking for main. All right, and here is the main function. So what we're looking for is the entry point. So this is where the system stops doing system things, and it hands off the code execution to the actual program. So when you launch a program, there's DLLs or sorry, that's Windows, but there are linked libraries that have to be loaded. The system has to do some things. It calls a see if I can remember the syscall or the syscalls. I think it forks the process, and it essentially the process that launches it creates a child process. It sort of copies over the structure in /proc, copies over any essentially the basic structure of an executable binary in Linux from the parent, and then it starts reading the child, the elf binary, and starts loading those linked libraries and whatever, until it finally gets to the point where it's actually going to execute the user code, and that's going to be our entry point. And that's usually going to be main. So we've found our entry point here at main, and what we can do, we can simply run PDF, which is print disassembly function, and that's going to print the main function. So we'll do PDF at main, and here we go. We can see this is the assembly code for main. Now before that starts, we can see up here we've got some variables defined. There's a brief discussion about those. Sorry, we'll get to a brief discussion about those after it goes into a primer on assembly and how all that works. So we're talking about some registers here. So there's different types of registers, different types of data. Talking about the size of data. So we've got, a byte, a word, a double word, a quad, a single precision, and double precision, and how, the sizes of those. It talks about memory manipulation and using registers, some basic instructions here. All right, now let's actually walk through the assembly code to see what the instructions mean when combined. So if we look through this, yeah, like I said, so we start off here with these variables. So the var tells us it's a variable, it's an integer. Here's the name of the variable, and then this is the address, the memory address location where that is stored. So for the challenge for today, what we're going to end up doing, we're going to essentially just track these variables through the program and see how they change. So the first thing we want to do is set a breakpoint. So a breakpoint specifies where the program should stop executing. So we're going to set a breakpoint. Let's see. And we want to do it. Yeah, we're going to do it. So if we let's see. All right, so as we go through the instructions, so it tells us to set the breakpoint here when we're moving the number 4 into the variable local ch. So that's one of the variables defined up here. So that's this instruction. So there's the address, so we can see it's the same address they tell us to use here. We use the db command to set a breakpoint. All right, so there's my address. Then we will db. Let's paste that in there. All right, now if we do a PDF app main again, we can see this B here tells us that we have a breakpoint set. So now that we have a breakpoint, we can run the command, just use DC. All right, we have run it, and that's interesting. We got an error. Let's see, did it run? Okay. Let's try that again. There we go. Okay, so I was trying to get prepped for the next part of this challenge, and I had the challenge one, or the actual challenge file open in another screen, and apparently since they're both ran the same system, Raidery didn't like that, and that caused an error. So I'll keep that in mind. But yeah, I've run it now, and we can see we've hit the breakpoint here. And if we look at PDF main, we can see here is this RIP. So we mentioned registers exist earlier. Didn't really say what they are, but a register is a memory address that exists on the CPU. So the CPU has memory on it, and the registers are specific memory addresses that are used for different CPU instructions. RIP, for example, is in RIP is stored it's the instruction pointer. So the address, so the RIP is always going to be a memory address, and it's going to point to the next instruction. So in this case, RIP should be equal to this address, this one we set the breakpoint on, because that is the next instruction to run. And this tells us here this is where RIP is currently at in this instruction set. So it broke where we wanted it to, and what it's doing is it's moving 4 into local ch. Let's see. So to view the contents of local ch, we can use the instruction px and then at the memory address. So in this case, the memory address will be rbp0xc because that is the address for the variable local ch. So we can do px at rbp-0xc. And here is the variable. So it is a 4-byte, an integer is 4 bytes. If you're not too familiar with how hexadecimal and bits and bytes and all that work, when you're looking at hexadecimal, every 2 characters is a byte. So any byte can be represented in 2 hexadecimal characters. So they go from 00 all the way up to FF. All those can be represented in 1 byte, which is 8 bits. So that would be 00000000 through 11111111. All that's represented in these 2 characters. So when we've got 4 bytes, we've got 8 hexadecimal characters. Now we set the breakpoint before we actually assigned the value. So this is currently empty. So we can see here at this address that the value is currently 0 because nothing's been assigned yet. Now we're going to step through. We're going to execute the next instruction. We'll use the ds command for that. Now if we go back and look at PDF main, or use the PDF command to look at main, we can see that RIP has moved on to the next instruction. So this instruction has run. So we should see, if we look at that address again, we should see that the value 4 has been placed into this variable. So let's run that command again, that px command. And here we go. We can see 4. So just a quick discussion on Indianness. So in computer architectures, there's a thing called Indianness, which is there's big Indian or little Indian. That's spelled with an E, by the way, ENDIAN. And that describes essentially the order that data is represented in memory. So it's a matter of, do you have the least significant bit first, or the highest significant or the most significant bit first? So in this case, it is the least significant bit first, which I believe is little Indian. So the least significant byte. So this is 4. It's 0, 0, 0, 0, 0, 0, 4. But because it's a little Indian, we actually see that last byte, that 0, 4 first. So if it was a larger number and you wanted to just convert it from hexadecimal to decimal, you would have to take each byte and reverse it by byte. No, don't just reverse the numbers. You do it by byte, which again is 2 characters. So this would be 0, 0, 0, 0, 0, 0, 0, 4, and you convert that from hex to decimal. Now, in this case, 4 is the same in hex and decimal, so there's really nothing to convert. Okay, and if we keep stepping through, we can see the same thing for the other variables. So we can look at local 8H. Let's see, local 8H. Let's look at main again. All right, so local 8H is at this address, so we can look at that. And I believe that is it here, and it is currently set to 0. So if we step through and we look again, I'm sorry, nope, it was here. It did have a value in it, but it's been changed now to 5, because if we look at main, we can see that this next instruction is moving 5 into local 8H. All right, then we move local CH into EDX. So again, talking about CPU registers, there are a number of registers. Was there a list? Here we go. Talking about registers. So we've got, RAX, RBX, RCX, RDX. These are all general purpose registers. RIP is your instruction pointer. RSP is your stack pointer. Those are the, important ones. We won't go into a detailed discussion of all those, but let's look at what our registers currently look at like. So we'll run dr, so we can see all our values. Of course, RIP is our instruction pointer. The next instruction we're going to do is we're going to move local CH, which is currently set to 4, into EDX. So we can see here RDX has a memory address, or some value there. And by the way, what's the difference between EDX and RDX? RDX is the 64-bit register. EDX is the 32-bit register, but it's just the lower 32 bits of the 64-bit register. So if we take the value of EDX and just put a bunch of zeros in front of it until we get a 64 bits, that'll be RDX. So EDX is just the last half of that. Let's go ahead and do the next instruction. So we'll take a look at main again. We can see We run that instruction, so we should see the value of local CH, which was number 4 in EDX. So if we look at our registers, we can see now that RDX is 4. All right, so we keep doing that. Next, we move local 8H into EAX. So we can step, look at our registers again, and now we can see there it is. RAX is now 5 because that was the value of that that variable. Let's see, which variable was that? It was local 8H. All right. Now we're going to add EAX and EDX. So we can step through that. Let's look at our registers. All right, so what we've done is we've actually added EDX to EAX. So now EAX has the value that returned. So we had 5 in EAX, we had 4 in EDX or RDX, and then added them, and that came up with 9. Then, you know, some more stuff's moved around, and then we move 0 into EAX. So we do that because we're going to do a system call. The system calls for printf, and the value of EAX is sometimes used to store results from functions. So we're just kind of cleaning that up before we run the function, just in case if there's a value that's left over and maybe the function doesn't return anything, the system doesn't think that it did return something. So let's see, what are we doing here? So we're going to do our add, then we're moving we're moving the results of EAX into local 4H, which was the third variable. Then we move 4H into ECX, 8H into EDX, and CH into EAX. So let's step through that a few times. See where I'm at. Okay, so what we should see here, so EDX should hold local CH, which should be 4. So let's see, RDX, sorry, it's 5. 8H, sorry, ECX is 9, which was the results. Right, so that's when we added them, the result was 9. That moves into ECX. 8H was 5, so that goes into EDX, and then EAX. Looks like I need to step one more time. Or wait, no, maybe I already did. Where are we at here? Okay, so that should be an EAX. There we go. Yeah, so 4 is in EAX. All right. Sorry, the colors on this are a little weird. It's kind of hard for me to see it. Old Man Bam's eyes aren't so great. All right. So we've moved those in there in the registers where we expect. Then we're going to move ESI to EAX. So move some more registers around. This LEA. So what is LEA? Well, we can see up here. Oh, I must have passed it. There we go. So it sets the destination to the address denoted by the expression in source. So there's a it's kind of analyzed this all for us, but essentially it's moving a memory address into RDI, and what this is showing us is what's actually in that memory address. So what we have is a string, and when we run this command, what it basically says is the value of It just prints out the value of each variable. So yeah, right here we can see the value of A, the value of B, and the value of C, A, B, and C being the three variables that we're looking at. So it's going to print those, or it's going to print this string and then insert the variables that we've been playing around with as we execute this code. Then it calls printf, then it moves 0 to EAX, and then it exits. So that's a very brief kind of explanation of how that all works. But let's go ahead and quit that. And just to show you what that looks like. So these are the files. So if I run file 1, yeah, there we go. So the value of A is 4, the value of B is 5, and the value of C is 9. It didn't print a new line, so we kind of see our prompt here as well. Yeah, that's what that was doing, and we saw it 4 and 5 were defined, and then it calculated 9 for us. All right, now let's take a look at the next file. So this is challenge 1. So we're going to analyze it. And yeah, I tried to do this before, but apparently having analyzing two completely different files at the same time, Ratery had some issues with that. So this might take a minute to run. We just got to wait for the analysis to run. And it's going to be very similar, but probably a little simpler than file 1. We're going to go through and look at the variables and see how they change as the code is executed. While that is running, just a reminder, I do have a CTF coming up. I have a little bit more detail about that. So it is going to be on January the 14th. We're going to go from 10 a.m. to 4 p.m. Central Time. That's U.S. Central Time. And this is sponsored by Huntress Labs. We've got some people from Huntress that are going to be joining us. We're going to be live streaming through the entire event. So John Hammond, who is pretty well known in the CTF community, he's going to be joining me, and Dave Kleinetland. No idea if that's how we say it. Sorry, Dave. He's also from Huntress. He's going to be joining us for most of the stream, if not all of it. He's still kind of clearing his schedule. But John and Dave are going to be joining me, and then I'm hoping to get some people from Perch as well to join, and we're going to be playing some video games, talking about hacking and about CTFs. And then for prizes, so this is where Huntress has sponsored us. For first place, they are making a Huntress humidor. So they're having it a customized laser engraved humidor made with the Huntress themed. I haven't seen exactly what that looks like yet. Their marketing team is still kind of playing around with some ideas, but I'm pretty excited about that. So you get the Huntress humidor plus 6-month subscription to TryHackMe. Second place is a $100 Amazon gift card plus a 3-month subscription to TryHackMe, and third place will be a $50 Amazon gift card plus a 1-month subscription to TryHackMe. So thanks to Huntress, and John Hammond kind of pulled some strings with the TryHackMe crew and got us some subscriptions as well. So I'm pretty excited about all that. I am planning on making this a King of the Hill style CTF. So I haven't done one of those before. I've usually just done the Jeopardy style, running CTFD. Now I'm still kind of working on the scoring server and testing that out. Looking at a few different options, and that's why the registration page isn't up yet, because I haven't quite settled on a platform yet, but I'm intend to get that done by the end of this week. So we should have a registration link and all that by the end of this week, and then we'll get up on CTF time and all that. So that is coming up. I'm pretty excited about this, and it looks like Ratery is done with our analysis. All right, so let's start off by looking at main. All right, once again, we have 3 variables: local CH, local 8H, local 4H. And let's see. So here's our challenge. So we're going to run Ratery to analyze challenge 1. All right. So what is the value of local CH when its corresponding move instruction is called the first time? So where's local CH first referenced? And it is here. And we can see that 1 is moved into local CH. So the answer to the first one is 1. All right, what is EAX when the multiply instruction? So imul is multiply, add was add, imul is multiply. So what is the value of EAX when this is called? And here it is. So we can see that we're multiplying local 8H, and it works the same as add. So we're multiplying 8H by EAX, and then the results are stored in EAX. Well, what's in EAX? We can see here that CH was moved into EAX. And so what is CH? Well, CH is 1. So essentially we're multiplying 8H, which is 6. So here we move 6 into 8H, 1 into CH. When you multiply those, you also get 6. So the value of the instruction is 6. And the value of 4H before EAX is set to 0. So we move EAX, which was the result of our multiplication, that's moved back into local 4H. And then we see 0 is moved into EAX. So again, this was 6. Now we could kind of step through that and I could show you, but we kind of did some of that already. And it's just a very simple, short bit of code. So I think we can, we were able to kind of just look through it and see what's happening without actually stepping through everything. And let's go ahead and move on, because we've got 3 more challenges to try to get through, and I try to keep these at about an hour. And I was a bit long-winded on that one. So let's go ahead and deploy the next machine. All right, so more reverse engineering, but this time we're going to start looking into .NET. So we need to get the attack box up and running, deployed, waiting on that to finish. So we started with it. Now we're talking about the .NET framework, which is a popular platform for software development, anything Windows or web. So there's an example given here. Here's some things you can use to disassemble .NET. There's ILSpy and .peek. I've also used dnspy, although they don't mention it here. It's very similar to ILSpy. Anyway, they give you a breakdown of kind of how ILSpy works, and then we get to the challenge. So we're gonna wait a minute here for the target to finish deploying, and then we'll get an IP address. So we're going to deploy the instance. So we're going to RDP into it because this is a Windows box. And then there's an application on the desktop, this tbfc app.exe. Basically just ask for a password. So we can use Rimina on the TryHackMe box, attack box to connect to the instance over RDP. So let's go to Applications, Internet, Rimina. We can cancel this. It walks you through every bit of it here. So we need the IP address of the target instance you deployed. Make sure you set the color depth to remote FX32 BPP. Otherwise, it won't connect successfully. So let's make a new connection. We'll do a quick connect. We've got the server IP 34.43, username cmnatic, and the password is advent of cyber exclamation. And then, like it was saying here, the color depth, this won't work. This value won't work, so we need to change this to remote FX. There we go. All right, connect. Do we want to accept the certificate? Yes, we do. All right, it's logging in now. So we're going to take the TBFC app, load it into ILSpy. Real quick, let's see what this app does. All right, so it asks for a password. I'm just going to type in password. Oh, that's the wrong key. Okay, so how are we going to disassemble this? Well, let's just load it in ILSpy. We can just drag this over ILSpy and it'll open for us. There we go. All right. And it's already decompiled everything for us as well. So let's look at this TBFC app. These are all different libraries, different DLLs that were needed by the .NET framework. We can see they're part of the .NET framework here. All right, so these are the different functions inside of this application, and we can see this CrackB. That looks pretty interesting. Let's look at that. So we've got an about form. So these are different forms. These are essentially the different windows that you see in a Windows application or a .NET application. There's an about form, and then there is a main form. The main form is most likely what we want to take a look at. And let's just look through this to see what we have. So all right, we're defining all the different elements that make up the form. So there's a label, a text box, there's the panel everything sits on, there's a button. So we're just defining all of those, and then we're defining what happens when you interact with those. So, for example, when the form loads, well, nothing happens there. Nothing happens when it exits except it calls the close function. There's the about click, which is going to load that about form here. So it just shows that. And then there's this activate click. Now this is the thing that's more interesting. So we can see here what this does. It shows, so it loads it does some stuff up here. We'll come back to that. And then we get some messages. So there's the, oh no, that's the wrong key. So that's what happened when I just typed in password, which was the wrong password. Then we have this other one, which says, welcome Santa, here's your flag. This actually gives us not the password, but it gives us the last one, which is what is the flag. When we get the password right, it'll show us that, but we can actually just see it here directly in the source code. Now, what is the password? How does that work? Well, that's what all of this up here is doing. It's taking what we've input and comparing it to something. And if we look here, so we're loading a variable, we're creating a variable and we're loading some data into it. Let's see what that data is. So it's got a pointer, and one of the things about ILSpy, it's loaded the actual data for us into it. And we can see here this Santa password 321. This is most likely our password, so we can test that. Let's run this and see if this works. Santa password 321. And there we go. So that does it for that challenge. Now, I kind of rushed through that just because I spent so much time on the last one. And it's .NET. It's a lot simpler than working with x86 64 assembly. But if you want to get a more in-depth explanation of how that works, John Hammond did a video. The link's up here, so you can definitely check that out. All right, let's terminate that box and move on to the next day. So we've got 2 left. Let's deploy this box. All right, Santa's released a web app that lets the children of the world check whether they are currently on the naughty or the nice list. Unfortunately, the elf who coded it exposed more things than she thought. Can you access the list administration and ensure every child gets a present from Santa this year? Feel free to try hacking this web app on your own or follow the instructions below. Note, when bypassing the hostname filter, use localtest.me. Otherwise, your attempts won't work. And if you can't, if you fail, there is a video here. If you, don't like mine and you want to watch somebody else, this is from the actual creator, which is Tiberius. Watch him solve it. All right, so for this, we're going to use a server-side request forgery. So this is a web app vulnerability that allows attackers to force the web application to make requests to resources it normally wouldn't. For example, the web app may have the functionality to produce screenshots of other websites when a user supplies a URL. This is perfect valid perfectly valid functionality. However, URLs can also be made for internal IP addresses, such as, the RFC 1918 IPs, which are the internal non-routable or not non-public IPs, and then, localhost, which is 127.0.0.1, as well as internal only host names. If web developer is not careful, an attacker could provide the app with these and manage to get screenshots of internal resources, which often have less protections. So to counter this, user-provided URLs can be checked before they are requested to ensure that malicious values are not being used. However, due to the complex nature of URLs themselves, there are often many things an attacker can do to bypass these checks. Note that while the example of SSRF used in this task is effectively a remote file inclusion vulnerability as well, not every SSRF is. Some SSRF vulnerabilities only trigger a DNS lookup, while others may not return any kind of response to the web app, but can still be used to port scan internal systems by measuring the time which each request takes to complete. In other cases, SSRF can be used as a form of a denial of service, since the attacker can continually request that the server download large files simultaneously, taking up memory disk space and network bandwidth. All right, so we're going to, we've got the VM deployed. We're going to connect to that. Let's close out everything we've done so far. And let's load this web app and see what this looks like. So it's at 10.10.138.223. All right. So here we go. We've got an admin login at the bottom of the page, and then we just have a search. So let's have a search. Let's see. Am I on the naughty or the nice list? Looks like BAMD is on the nice list. I think Santa hasn't been watching. All right, so we enter name, hit search, and we can see the URL up here, and they break it down for you here. So what it's actually doing when we run this, it's got a parameter called proxy, and that's going to another site. So this is URL encoded. So %3a, 3a is the hexadecimal value for the ASCII, the actual character, a colon. So we've got HTTP : / list.hoho : 8080. So again, the 3A is a colon, so it's on port 8080, and then we've got a / search.php. 3F is a question mark, name, and then equals Tiberius, or in my case, it should be BAMD. There we go. So we can decode that. Yeah, okay, he already did that for us here. Since list.hohoho is not a valid host name on the internet, .hohoho is not a TLD or top level domain. This host name likely refers back to some backend machine. So it seems like the web app works by taking this URL, making a request to the backend, and then returning the results to the front end. So if the developer is not careful, we may be able to exploit this using SSRF. So the most obvious thing we can do is to fetch the root of the same site. So what we can do, we can take the URL we already have here, and let's delete the end of it. So we're just ending with that %2f before the search, which is that slash. So that would be up to here. Oh, sorry, not the search, but starting with this this slash that's right there. All right, let's run that. Let's see what that returns, and we actually get a not found. So it looks like it is working. There isn't a page that's at the root of the web server, so we're getting a 404 back, and it's just displaying the 404. So we've confirmed this at least can do some SSRF. Now we can try changing the port numbers. Again, this can be used for port scanning, so we can see, for example, connection refused. If we do port 22, we get receive failure, connection reset by peer, which suggests that port 22 is open but did not understand what was sent. let's go ahead and do that real quick. So instead of 8080, we will do 22. And just like they said in the tutorial, we get this receive failure connection reset by peer. So we can use that to enumerate open ports. Something else we could do is we could try to connect to localhost. So instead of list.ho, we can do localhost. So this search has been blocked by the security team. So they at least do have some basic security in place. So how can we bypass that? Well, in this case, they're telling us the developers implemented a check to ensure the host name provided starts with list.ho and blocks any other host names. Well, that's great. Now, what can we do with that? Well, if we have our own domain name, we can do a subdomain of list.ho, for example, evilsite.com, and we should be able to get it to load that page. And have it, for example, we could, if we own the DNS for this, we can resolve it to 127.0.0.1. You don't even need to buy a domain or configure the DNS because there are already multiple domains that exist that do this. So the one we're going to use is localtest.me. So localtest.me, you can provide any subdomain for that you want. It's always going to return 127.0.0.1. So we can therefore set our host name in the URL to list.localtest.me. So instead of localhost, let's do list.ho.localtest.me. Whoops. All right, what did I do wrong? Oh, I guess my H key was sticking. Just typed who instead of ho. There we go. And now on the localhost, we can actually see there is a web page, and it says Santa. If you need to make any changes to the naughty or nice list, you need to log in. I know you have trouble remembering your password, so here it is. Be good for goodness sake. All right, so let's see what do we want to do. What is Santa's password? It is be good for goodness sake. Now, what do we need to do? We need to log in as an admin and delete the naughty list to get our challenge flag. So we don't have the username, but we can guess it is for Santa, and the password is be good for goodness sake, exclamation. All right, so this brought us to the list administration. There's not much here, but we can delete the naughty list and get our flag. So that does it for this one. This was also pretty straightforward. They've really done a good job, and TryHackMe does a really great job on teaching you things as you interact with the challenges. Some great tutorials here. All right, now let's look at some PowerShell. So this is day 20. PowerShell to the rescue. All right, someone is mischievous at the Best Festival Company. The contents within the stockings have been removed. A clue was left in one of the stockings that hints that the contents have been hidden within Elf Station 1. McEager moves quickly, attempts to RDP in the machine. Yikes, he's unable to. Luckily, he's been learning PowerShell, and he can remote into the workstation using PowerShell over SSH. So we're going to use the PowerShell console to navigate through the endpoint to find hidden contents to reveal what was hidden in the stockings. Oh, excuse me. I think I need a drink of water. Okay. So let's, we're going to SSH in first. Yep, there's a password here. Okay, so SSH, we are McEager at 10.10.138.223. Yes, password rock star exclamation. Yep. All right, what am I typing wrong here? Let's just put this in the clipboard. Paste that in there. All right, let's just copy this whole thing. Ten ten 138.223. Okay, that's the right IP. Okay, let me read these instructions again. Don't know what I'm missing. You'll use SSH to connect to the remote machine. The command to run to connect to the remote machine is this, which I copy and pasted. When prompted, enter the password rockstar, which I also copy and pasted, right? There's no extra spaces on the end. All right, so I don't know what's wrong there. Let's. Oh, yeah, there's definitely something wrong. I can't even terminate the box. Oh, it's still on the naughty or nice list. Okay. That's the problem. We're on the wrong box. I thought that IP sounded familiar. It's not letting me terminate it. All right, let's just refresh. Okay, now we can terminate that box. Okay, so something happened when I tried to terminate that box. I don't know what, but it didn't work. But that's why we couldn't connect. We're still trying to connect to the previous challenge. All right, so we'll give this a minute to start back up. While that machine is getting started, there is a kind of a tutorial here on PowerShell and some basics. Essentially, all we're going to do through this challenge is try to find some hidden files and hidden directories using PowerShell and then read those files. So we're going to use, let's see, so we use set location to move to a directory. You can also use CD. You can use get child items or get child item, the cmdlet, to view the contents of the current directory or a given path. It's got some different flags, like you want to filter for files or directories. Do you want to get, for example, only hidden files? You can use the -hidden flag. So we're going to go through that, look for hidden files, and it kind of gives us the command here to do that as well. Let's see if our box is up yet. Not quite. I thought that box had loaded pretty quickly the first time around. It's because it's the wrong box. All right, so we're going to use get child item, and we'll use get content to view the contents of a file. And I think that's pretty much it as far as the commands. Oh, no, wait, sorry. There was a select string that is there as well. So let's see if I can remember how to do all this. I do not use PowerShell often, I must admit. I spend way more time on Linux than I do Windows. So let's see how well I do this time. All right, let's try to SSH again, this time with the correct IP. All right, 10.10.175.213. And the password. Oh, let's see. Give this a minute to load. And it should be rock star. Oh, looks like it's going to let us in this time. All right, success. Figured out how to SSH. All right, now let's launch PowerShell. All right, we've got our PowerShell prompt we can see here because it says PS. Let's just go ahead and jump down to our discussion here. So search for the first hidden ELF file within the documents folder. Read the contents of the file. What does ELF1 want? All right, so we're in C users McEager. We can do set location documents. Let's see, we should be able to tab complete. There we go. All right, so we are in the McEager's documents directory and search for the first hidden file. So again, if we look up here, here is a command we can do to search for hidden files. So we're going to use get child item, looking for a file with a hidden, and then this is just in case we run an error. We don't need to see any errors. So for example, if there was a file or a directory we didn't currently have permission for, it would give us an error about permission. So this just kind of bypasses that. We don't need to see it. So for example, in Linux, just doing a to greater than dev null, which redirects std out to dev null, is how I would normally do that. All right, so let that run, and we can see there are two files in the documents. There is this desktop.ini and this elf. It's e1 phone or elf1.txt. So we need to get that. So we can do get content path and e1 phone.txt, and that gives us the content. So all I want is my two front teeth. So the answer to the first challenge is, what does he want? He wants his two front teeth. All right, now we're going to search on the desktop for a hidden folder. So, all right, I'm using, you can use the cd command as well. In fact, we can use ls to view files. And all right, that doesn't work. But all right, we're looking for a hidden folder. Okay, so we can use the previous command that we had done, which is that get child item, but instead of a file, we're going to change this option, and it tells us what the options are up here. So we're going to want a directory. So I'm going to erase file and make that a directory. All right, and that's, yeah, the way it's doing the coloring there is kind of hard to see, but hopefully I got that right. Okay, so we see there is a hidden directory called elf2w0. So, okay, so then we need to go into that directory and read the contents of that file. So we're going to move into elf2w0. Let's see if tab complete works. It does. Just going to run ls to see what's in here. Yep, there is one file. And we're going to get content for this file name. I want the movie Scrooged. So that would be the answer to the next question. What's the name of the movie that Elf 2 wants? All right, now we need to go to the Windows directory and look for a hidden folder. This one contains files for Elf 3. Now, this one had me. This one took me a little bit because when it says the Windows folder, it actually means the Windows System 32 folder. So I actually had to go and watch the video by John Hammond that's linked at the top in order to figure that out. But we got that working. Let's see. We still should have that command from earlier in our history. There we go. So we're going to search for a hidden directory in the Windows System 32. And there we go. So there's another ELF directory for ELF 3. What is the name of the hidden folder? There it is. All right. Then how many words does the first file contain? What 2 words are at these indexes? All right. So let's go ahead and move into this directory now. Set location 3LFTHR tab. All right. That works. Let's see what's inside this directory. So we should have 2 files. Oh, nope. Looks like they are hidden. I still have that. Nope, I don't still have that in my. Just copy this command again because I'm lazy and I don't want to type it out. There we go. So there's file 1 and file 2. So the first question is, how many words are in the first files? Well, how do we figure that out? Well, they tell us up here, and it's actually this command. So we're going to get the contents of the file, and then we will do measure object word. So get content path 1.text. We're going to pipe that to measure object word. Yeah, thought I had a typo there. It's W-O-R-D. That's how you spell word, not W-R-O-D. And there we go. So the number of words, 9,999. So that was the answer to this question. And then what 2 words are at index 551 and 6991? Well, how do we figure that out? And we can see right here, we've got, how do we figure that out? So let's do that. So let's do get, let's do it exactly like they have it. Get content path 1.text. And then our index, the first one is, let's see, 551. And that word is red. And the next one, the next index is 6991. And that word is writer. So what 2 words are at index 551 and 6991? Red writer. But that's only half of the answer. So searching the second file for the phrase from the previous question to get the full answer. What does ELF3 want? And there is a hint here. So we're going to use the dash pattern red writer. So we're going to do it all lowercase with no spaces. And again, there is it tells us exactly kind of what we need to do here. So we will do select string path 2.text dash space dash pattern red writer. And here we can see that at this position inside this file, we've got red writer BB gun. And so the answer to the final question is, and it wants it all, you know, with camel case and spaces, red writer BB gun. And that would be the answer to that question. All right, so that does it for day 20. Yep, day 20. And that's all I'm doing today. Tomorrow I'm going to go through days 21 through 24, and then I'll actually be caught up. And then we'll do that final Christmas Day challenge on Saturday. So I think that does it for all the hacks for today. Thanks for watching. Thanks for your comments. Thanks for your help here in the chat. And just one more time, a reminder in case you missed it earlier, but there is a CTF coming up. This is a BAM CTF, so this is just one that I'm putting together, but I did manage to score some sponsorship from Huntress Labs. That's going to be January 14th, 10 a.m. to 4 p.m. Central Standard Time. John Hammond and Dave Kleinetlen from Huntress Labs are going to join me. I'm going to try to get some people from Perks to join me. We may have some other Huntress people that kind of come and go because we're going to live stream through the entire CTF. We're going to play some video games, talk about hacking. We actually intend on playing an FPS with a team CTF, so we're going to be doing a CTF while the CTF is going on. First place will be a Huntress-themed humidor plus a 6-month subscription to TryHackMe. Second place, a $100 Amazon gift card plus 3-month subscription to TryHackMe. And third place, a $50 Amazon gift card plus a 1-month subscription to TryHackMe. This will be an individual CTF, so there won't be any teams. I'm still working on the scoring server. Once I get that up and running, I'll have a registration link, and I will share that with you guys. It will be on my website, which is bamctf.com. Which also has links to all my archived videos and any other content I've created. Or you can follow me on Twitter at BAMCTF. That's BAMCTF, where you can also see any updates relating to this upcoming CTF. Really hope to have that registration link up and running by the end of this week. Just trying to it's going to be a King of the Hill style King of the Hill style CTF. And so normally I just use CTFD, but that's really only works for Jeopardy style CTF. So unless I can get a plugin to work or get another scoring engine up and running, we'll kind of see how that all works out. So I'm going to get that sorted out, and I'll let you guys know. Hopefully when I do the final Christmas Day hack on Saturday, I'll have that registration link and we can get that up and running. So that does it for today. Once again, thanks for watching. And next time you get stuck in a CTF, don't forget to try harder, don't panic, and always RTFM. Thanks for watching. Bye.
It's a madman, the